Archimedes and the area of a circle. Archimedes is said by some to be the greatest mathematician of the ancient world. Archimedes, son of artist-class astronomer Phidias, was born after Euclid in the Greek colony of Syracuse on the island of Sicily. During some point in his life, Archimedes studied in Alexandria in northern Egypt, an intellectual center of Greek learning at the time. One of Archimedes' discoveries is the equation called the law of the lever, which states, given a lever system, the system will balance only if the product of the weight and the distance from the fulcrum are the same on both sides. Regarding the law of the lever, Archimedes is reported to have said, "Give me a place to stand and a fulcrum for my lever, and I can lift the earth." Archimedes was renowned for mechanical and engineering genius, having designed parabolic mirrors to concentrate the sun's rays and set fire to attacking Roman ships, compound pulleys for lifting them, and a long screw used for launching ships. He also invented globe-like planetariums, ballistic devices or catapults, as well as the spiral screw in use of transportation of water to higher levels. Skeptical scholars of the burning mirrors were shown that they did indeed work when mechanical engineer of MIT, David Wallace, encouraged his students to replicate an oak warship. The students successfully set the ship ablaze 10 minutes after focusing 127 large mirrored tiles on it. Ballistic weaponry designed by Archimedes was effectively used against the Romans in the siege of 212 BC. Plutarch wrote, "When Archimedes began to ply his engines, he at once shot all sorts of missiles against the land forces, and immense masses of stone down with incredible noise and violence, against which no man could stand, for they knocked down these upon whom they fell in heaps." Plutarch also wrote of Archimedes and his eccentricity, in that his servants at times had to force him to bathe. Archimedes was so single-mindedly devoted to mathematics, he would quote-unquote forget his food and neglect his person to the degree that when he occasionally was carried by absolute violence to bathe or have his body anointed, he used to trace geometric figures in the ashes of the fire and diagrams in the oil on his body, being in a state of entire preoccupation and in the truest sense divine possession with his love and delight in science. Archimedes is most famously known for his exclamation, "Eureka, Eureka," the translation being, "I have found it, I have found it." This is said to have erupted from his mouth as he pondered while bathing in a public bath. He reportedly ran home naked after he noticed the volume of his body was equal to the amount of water displaced from the tub. This application was the beginning of a solution of a problem presented by King Heron of Syracuse, who suspected the pilfering of gold from his crown and replacement with an equal amount of silver. Despite such crowning achievements in engineering, Archimedes was most proud of his mathematical discoveries. They include the formulas for the area of a circle, pi r squared, the volume of a sphere, 4/3 pi r cubed, the surface area of a sphere, 4 pi r squared, and analysis of properties of parabolas and conics. The mathematical foundation on which Archimedes rests is a series of treatises on the geometrical and physical properties of figures bounded by lines, curves, or surfaces. The treatises are as follows: on the sphere and cylinder, measurement of a circle, where he derives pi, on conoids and spheroids, on spirals, on the equilibrium of planes, quadrature of the parabola, on floating bodies, and the method of mechanical theorems. Archimedes based his calculations for the perimeter of a circle, and hence his close approximation of pi, by inscribing a 96-sided polygon both closely inside and outside a circle, calculating the perimeter of both, and acknowledging that the perimeter or circumference of the circle had to lie somewhere between. He quotes, Thus, by continuing the process, we shall ultimately arrive at a circumscribed polygon such that the spaces intercepted between it and the circle are together less than the excess of k, or the variable. Archimedes stated, the ration of the circumference of any circle to its diameter is less than 3 1/7, but greater than 3 10/71. Averaging the two numbers yields 3 149 thousandths, which is less than 10 thousandths from the true value of pi. Even more amazingly, Archimedes calculated this without the benefit of decimals or a symbol for zero. The treatise, The Measurement of the Circle, stood as the recorded value of pi until Claudius Ptolemy used 3 17/120, almost 200 years later in Alexandria. This treatise contains one of Archimedes' most accessible mathematical achievements in that it contained the determination of the constant pi. Also proven by Archimedes was that the area of a circle is equal to that of a right triangle, and that it has one side equal to the circle's radius and the second side equal to that of the circumference. And more importantly, the area of a circle was found by approximation with an n-gon inscribed inside a circle. Early Arabic mathematicians, including 10th century geometer Abu Sal Akui, credit Archimedes with both an elaborate technique to create a regular heptagon, which was said to be impossible at the time, with only a compass and straight edge, and refer to him as the Imam, or divinely appointed, of mathematics. For calculations and heavy-duty mathematics, Archimedes probably made use of a common counting board, which was a precursor of the abacus. The counting board could have been a tray filled with fine sand, or could have been a tray constructed of wood or marble with marked columns for counting arranged beads. In 212 BC, Syracuse was besieged by the Romans while Archimedes was within the city walls. At the time, he was 75 and was known as the greatest mathematician and physicist of the ancient world. Plutarch wrote of his demise, "It was chanced that he was alone examining a diagram closely, and having both his mind and eyes on the object of his inquiry, he perceived neither the inroad of the Romans nor the taking of the city. As a Roman soldier approached him, Archimedes ordered, 'Do not touch my circles.' The Roman soldier, having no clue who this old man was, or perhaps not caring, murdered him on the spot and went about his duties." According to the Greek writer Plutarch, Archimedes requested to have inscribed on his grave a cylinder and circumscribing a sphere, along with the ratio by which including the solid exceeds the included. Unlike Euclid, Archimedes' mathematical discoveries had little influence on humanity until the Arabs rediscovered and revived them sometime in the 8th century. In the 1500s, his works resurfaced and influenced the work of Kepler and Galileo. Kepler used a strategy similar to Archimedes in finding the area of a circle or the value of pi. In 1998, at a Christie's auction, a tattered medieval manuscript was sold for $2 million to an anonymous bidder. It was later turned over to Walters Art Museum in Baltimore for further study. The document, in fact, turned out to be a palimpsest, a parchment book whose original text had been scraped off and written over. Hidden beneath the script was a 13th century monk's prayer book, and under that was a faint trace of 10th century writing. In the treasure hunt that ensued came the revelation that Archimedes had bucked to the Greek system of mathematics at the time, which avoided the pitfall of infinity. The first proposition portion of the method that was salvaged revealed that Archimedes did, in fact, grasp infinity, speaking of the collection of all the parallel lines in the triangle. He promises in the introduction to provide proofs for some of the results, but unfortunately those pages have disappeared or were discarded. The Archimedes Codex, as this document is referred to, shows the full range of his mathematical genius, which was nearly 2,000 years ahead of modern science.